Welcome to section Object-Oriented Programming with F#. In this section, we will look at object-oriented capabilities of F#. Although it is a functional first language, F# has excellent object-oriented capabilities. In the first part, we will look at using classes and constructors. Then, we will study interfaces and class members, such as properties, members, methods. Thirdly, we will talk about interacting with .NET and C#. Since F# is a .NET programming language, it has excellent capabilities with interacting with .NET Framework as well as code written with C#. And finally, we will make a brief comparison of C# and F# in terms of capabilities and syntax. Let's start our adventure for object-oriented programming from using classes and constructors. Basically, for class syntax in F# there are two different implementations. One is explicit syntax and the other one is implicit syntax. Here in the code below, we can see an example for the explicit syntax. Let's go through this in detail. Now let's see some examples regarding these class syntaxes. Here in the first code, we have some example for explicit syntax. We have a class called employee, and actually the syntax is like type employee equals class, and actually this class and the and keyword is optional. In F# light syntax, you don't have to type this. So you suppose that if I delete these and class keywords, we're totally fine. And here we can see three class fields. In this case, I have age, full name, and department. Age as an integer, and full name as a string, and department as a string. And I marked department as mutable, in which we can change the value once it has been assigned. Actually, if you know C#, you can consider these two fields as read-only fields, whereas this is a non-read-only field. Here we can see two constructors. Actually, in this explicit syntax, in the first constructor, we are creating a new full name, age, department, and we are basically setting the fields with the following syntax. We open curly braces, and we make one-to-one assignments directly to the fields. And here we have another constructor. Actually, this constructor makes use of the other constructor. In this case, we have department parameter missing. So we decided to pass a default value for the department. So in order to do that, we can just invoke the constructor as this syntax. Now suppose that I want to run some code after the constructor. What I would do is to use then. So I write then I can write any arbitrary code, printf, %a, hello from constructor. This is fine. However, suppose that I want to assign some other value on the department. So to do that, what I will do is that department equals some department. But this doesn't work. Actually, notice that this green line indicates a warning. Actually, we never do assignments with the equals operator. This equals actually is a binary equal operator. So to do our assignments, we use this operator, which is less than dash. However, we have another problem. Now the compiler states that the value is not mutable, but we have marked as mutable. Why is that so? Because in this case, we did not define a context. So by department, actually F# refers to this parameter. In F#, not only the fields are immutable, but unlike C#, our functional parameters are immutable too by default. So what we should do, instead we want to modify this department field. So let's try this keyword. This doesn't work either, because in F# this keyword is not a special keyword. In order to make our compiler to recognize it, actually we can use of as. After our constructor, we can state as this. And now everything works fine. Actually, in this case, this is not a special keyword. I can write any arbitrary identifier. I can write emp for employee. Now everything works fine, and actually Visual Studio Code denotes that our constructor takes three parameters: string, int, and string, and it returns an employee. Let's see the implicit syntax. Implicit syntax is much more concise. Again, I can delete class and end keywords, which are optional, and we have a constructor directly within the type definition. We call this primary constructor. Actually, if you're familiar with JavaScript and TypeScript, you will notice this is essentially the same thing. And at some point, designers of C# tried to use this construct, but somehow they gave up. And actually, once I have defined this constructor, I can make use of these variables directly within my code. No need to assign them to fields. Actually, in the class definition, I can use arbitrary let bindings. These are not for execution code, but they are sort of fields, but they are not actual fields. And finally, if I want to execute some code, I use do syntax. And this actually refers to code that is executed within the constructor. So in this case, I'm just printing my x variable. What if I want an additional constructor? In this case, I can still use my new keyword. New and full name, age, and I'm passing the other as a default parameter to my department. But note that, in this case, the compiler was not able to figure out the types. So it thinks full name and age as obj, which refers to system.object. What should we do? For example, I could have done the following. Instead of x, if I were to print the age, then suddenly the age parameter becomes integer. Because from this %i, F# compiler can infer this parameter is an integer. However, in order to help compiler, I can give some hints. As such, string, int, and string. Now the compiler can infer the correct types. As an example, we can make use of our classes. Let's type let e1 equals employee, full name is owner, whereas age is 37 and department is software. As you see, unlike other languages, we don't have to use new keyword. Actually, new keyword for classes has another use. We will see that later. Also, we can make use of our second class. E2 employee 2 and 27. These are two class instances we can make use of.